All right. So I suppose even now I'm not gonna use the camera because it happens in classes. But let's see. So I will be just green, having the microphone, and that's it. All right. So at this point, you're only two connected. But okay. Anyways, we start kind of a step by step in all of those things. All right. Maybe you have seen that. Okay. So now we shared, and now I'm gonna module system. So I play internet. If you like, you can download that afterward. But I'm just not really sure uh, if uh, if it correctly to be shared by the links or by the files. So that's why uh, it's the link for which is related to neural networks and their implementation. You can take a look on this material. I use all and it's programming with Java. What a really cool book! You can take a look on one. Um, well, amount of pages is not so. It has even codes which are related to different chapters. Also headings. Yeah. So you can go inside that folder and you can see that codes are split by chapters. You have a lot of example codes. It's up to you. If you like, you can take a look on that. If you don't like, well, if no, then no. All right, and the project which some time ago um, um, it was related to those agents. So um, literally you can for sure grab that from the GitHub, but it won't be. I will open it. And you know what I didn't figure out yesterday, unfortunately, that in that README there was already the scheme shown about all of the classes. So if I would have been attached to the engines. Anyway, I can do now. Okay, while it's loading, I will check the names. Oh, Okay, not really, not really. But okay, it is what it is. Um, let okay, I will the all of the tabs. And I can click on the readme. If I'm not mistaken, have no ago, there are not really much descriptions. Literally solution. All right. So yeah, literally here we have a list of classes, and we have those connections, those arrows, literally saying how classes are organized themselves. So literally, that so this arrow means especially when it's empty inside. That means that we have a component without which neural can. So the neural network driven agent can use M class. Right. So here we have one. Text as we have seen it yesterday, movement to the specific angle we by an or and when we have its extension to the neural network driven agent, so we have some parameters which for sure are needed for analysis, maybe for setting up some beginning values, and then we have the neural network in it. So yeah, here actually the story is super simple. In the neural network, we're capable to. Oh, okay. Again, I have this this problem highlighted. Actually, guys, when I was doing the falling add Maven dependency, I had to click this try update in Marvel indexes, and then I had to click this update, and then the icon. Um, but the thing is that the process is that thing, so it means we don't see how it's being downloaded. After I had the class, when I was switching off this Windows system, the Maven library was in right of my surround. So so in this case, I will just leave it as it is this window. And oh, okay, you see the updating happens. But again, the progress available. Okay, we have some update and progress bar, and as you can see, it doesn't happen fastly, right? So yeah, the only thing we can wait, but in the same time, guys, we have to have this library for compilation. Compiled code, the previously compiled code. Then what you have to do? Then you have to go to the folder where you have this project. Then you have to go anyways this file. To run that file, I suppose that we need to have the Java in the java.com website. At least previously it was okay. Let's accept this. We have to get this runtimes to run inductions. Applications. And then we're downloading that. Okay, the downloading speed is pretty low. I suppose it's because of the screen sharing. But I will be waiting for the file. On my side, I already see the red icon related to the internet connection. So yeah. So as I said, it's not reasonable to use camera. Okay, so it's been downloaded, so we can install it. Okay. And now if I can run that by double by the double click. This one, and yes, you can see it takes yeah. So yeah, what we have here? We have links between neurons, difference in the neural network. But again, this code is pretty full of varieties of actions, so so it's structured not in the super simple way. For example, guys, if you would be trying to go through materials, which I and the repository, no, you would find out the following. For example, if we use, let's say, the neuron, right? We can how it could be organized, right? You can find out your system is not really um, kind of used everywhere, but still it's used, and you can just find a lot of systems what and how you can implement. Okay, so until this library will be much. Hmm. Yes, I suppose that we can try to think of, of the neural network, which I will ask you to develop using different another is which is not included. So literally, probably you have seen check a screen. Yeah. So we have a computer vision, and I will ask you method and the neural network method. Let's maybe take a look on what is the computer vision exactly as. We will maybe simple words and the way definitely if you use it. So guys, do you use somehow computer vision daily? What would you say? Sense I guess, sense I guess means no, right? Okay, what's about the case when you open your mobile phone by your face? Do you use such options? Yes or no? Well, yes. And for example, you can even make a picture or a screenshot of the text text from those pictures. Do you use such option? Yeah. My, it has um oh, again I have that red sign, so I will maybe switch the internet connection. So wait a bit, guys, please.
You are currently the only person in this conference.
Okay, so I switched the network. Um, okay, I really hope we're good now. All right, so what I was about. Oh yeah, I was asking you if you're using the computer vision stuff. So for example, we can make screenshots, we can copy text from that. We can even make the tracking option when, for example, we have some camera, for example, attached to the house, and that camera tracks for the persons or cars which are moving around. So all these things are based in all these things under computer vision, and well, regularly we use that data. Sometimes we don't even recognize that's something specific, like computer vision stuff or whatever. And this time I would like to show you one of materials. Um, Actually, by the way, that material was, well, I created that well, literally years ago. It was actually the things which I will show you in the computer vision presentation. Actually, all of this is mostly taken from my bachelor thesis. Yeah. Well, and I didn't have a time to convert this presentation from the regular one which I prepared for Liepa University. But again, it doesn't matter. Literally, the main is information. So yeah. So what fields computer vision is in car plate number recognition, barcode recognition, recognition of the texts in books. For example, well, maybe you know they are very simplified equipment. Well, which which is somewhat similar by the size as the mobile phone, which blind people can use and can pull around the pages of the regular books. I mean printed books, and such device can memorize the text under its camera, and can even um, uh, convert that to sounds and literally tell the text which is written in books. Well, such solutions they exist, by the way, so it's not something well imagined, or let's call it only imagined. Such things exist. There is automatical filtering of printed documents, which is really um, a big problem for companies which at least had, let's call it that way, at least had paper only documentation, as well as such field is related to old tags in warehouses. What does it mean, the old tags, and why is it a problem? Well, you can imagine something, some tag, which text became so moldy, so you can not really read that. You don't understand what's written there, but uh, but the thing is that machine or computer can understand that, still can understand the text, so can recognize that. Well, the next thing, which is very popular, is the registration railway station wagons. So literally, there are cameras which take a look on the wagons which have been taken from one place to another place, and once they see the number plate, they register the number, and by that number, systems automatically receive information that this or that wagons they appeared at this or that station. Literally, such solution is used almost on every railway station. I mean, which have been modern for some decade. Um, for sure, some of those which were not updated, some maybe 20 year during the 20 years they might be not having such solution, but all of those which are used nowadays and they're up to date, they all have the system. Another thing that is ATM. So when you put the cash inside, because we can have ATMs which can give you the cash from your bank account, and there are ATMs in which you can put the money on your bank account, just pulling them inside. So even for these purposes, there are specific neural networks, and well, not only neural networks, but let's call them solutions, which provide this understanding if the banknote which you give to the ATM is fine, if it's correct, if it's legal, and so on and so on. So as you can see, there are a lot of usages of such thing of the computer vision. But in our case, um, it's not really practical to talk about some very complicated cases, because all of those cases which I mentioned here, they are well somehow complicated. Well, believe me or not, I've been making solutions for most of the points from this list we have on the screen right now. So the thing is that, by the way, commercial solutions, not just for fun. So what is interesting? The interesting thing is that the most simplified and the classical task is assumed to be a so-called OCR, optical character recognition. Um, have you ever heard something about the optical character recognition? Yes or no? Okay, it's understandable about the balance. So my question was for you. Um, have you ever heard something about optical character recognition? Mm-hmm. Okay, that's great. So let's understand what is it and how it's been implemented. Um, right. So mostly, systems they can analyze information not in the real time, but specific algorithms and specific optimization methods they allow to the modern systems to analyze pictures where we potentially can have some numbers to be recognized in the real time image processing method. Uh, So the first of all, you can find out um, which symbols are being shown on the pictures by different methods. You can take a look on a lot of these methods, but most of them will be a so-called classical and academical. So there are always cases how to make such solutions much faster working. Anyways, to implement something, you have to go through materials which are available. You have to think of, well, what are weak points of the solution. Then you need to create a so-called um, description of, or let's call it the first version of your app. Then you need to um, optimize that first version and so on and so on. We will overlook two methods, which assume to be very, very classical methods. Actually, if I remember correctly, there are approximately 8 basic methods which allow to do that, but we will take a look only on 2 of them. Primary, it's because we don't have a lot of time for overlooking the rest methods. I mean, besides this one. So the pattern recognition. I suppose it's understandable by, it calls pattern or template, no big difference. So by its name, it's understandable that we have some patterns, right? Which means that we have a library of images of all different sizes and all different stretches, which we can use for analysis, for literally for comparison between the picture which is given and such pictures from the library you have to prepare. So before running the analysis, you have to prepare a lot of such images. And the classical way for comparison is the pixel by pixel comparison. Okay, so what does it mean, a pixel? Well, I suppose you definitely know what is it, but let's talk about the pixel in the aspect of the symbol. So here we have a symbol. Well, I suppose everyone recognizes the symbol, so it's 1. And gray area is the border of this image. So literally, what is inside this folder is the content of the image, and it has 2 colors. It has the background color and the foreground color. We call the foreground color sometimes as significant color. So that term will be needed afterwards. And if you have a template and a given picture from the user, then you can find out the matching percentage between those, let's call them, 2 pictures. And here we can have an equation by which you can literally say what is the percentage of comparison, or let's call it, what is the percentage of the match between 2 images. So this approach is kind of very, very academical and popular. But as you understand, the strong side here would be if we have exact picture of the symbol which is given, then we can say with the 100% and be sure that we found out a picture if the match percentage is 100%, right? So that would be the strong side of such approach. The weaknesses of this would be a comparison element, because comparing pixel by pixel, well, it's really time taken, because there will be millions or even milliards of um, pixels to be compared. Well, that depends on the symbol library. So as you understand, this method by itself is somehow slow. So potential improvement of such method, or let's call it optimization, would be changing the comparison element, for example. Um, because critical points are size of the library, comparing elements, slow speed of that, because every size picture should be included into analysis. So that's really slow. Yeah. So so a kind of the classical for nowadays solution would be using a sector comparison, which are proportionally same for different sized symbols. Which, okay, for example, you see, proportionally it's the same area as we have here for the large symbol, but in the same time, for the smaller symbol, that one could take, let's say, 1 pixel, that area. But for the bigger symbol, bigger 2 times, right? Such could be consistent of 4 pixels. Well, and then it means that looking for the average, let's call it color of the region. For the smaller image, you can take just entire pixels color, but for the bigger one, you will have to calculate the average color. And then, yeah, when such things are possible, then it's possible to implement such and use such thing as two-dimensional density, which is a calculation for the sector, which is being doable in a such way. So we have amount of significant pixels, and we have amount of all pixels of the region, and we multiply that by 100%. So by that we can find out the density of the area. Um, well, um, well, it's interesting that such approach it allows to reduce amount of different sized symbols in the library. So you can just store a very big image or maybe a very small one for these purposes. Yeah, because right now pixels are not involved in the comparison. What we receive in the end? Well, in the end, it means that besides the fact how big is the image, we can convert that to the matrix of the same sizes. And if it's so, let's take a look. For example, here we have, if I'm not mistaken, it was 16 cells in each direction. So afterwards, we'll need to compare the corresponding index sectors values to find out the match. And as you can understand, already this operation would be happening same fastly as for the case when we would be comparing two images with the sizes of 16 pixels in X and Y direction, which means super fast. So that's the benefit of such optimization of such method. Yeah, so you can see whatever size we have in a template library, we always receive the same result as this matrix, as these region values. Well, some of you might ask, well, how it happens that it could be true? Well, if you would take, for example, such proportions of symbols, And by the way, for these tables, I'm using the uppercase W letter. So you can use such proportions, and you will find out that for each letter in which you're using, uh, for different sizes of the image of the symbols image, you have approximately the same values for such proportions, like the height divided by the size, or width divided by the size. So you see values approximately the same, or amount of significant pixels divided by size square. Again, values approximately the same. Well, amount of all pixels um, of the symbol divided by the size square. Again, approximately same values, which means that we can really rely on such method of sectoring the image. Well, for example, here we could have a two-dimensional density of the whole image. Well, again, similar values. And sometimes, by the way, such procedure, which assumes to assumes to make Fourier comparisons, Fourier recognition. It firstly makes the colorful image as the black-white. So we receive components of the pixel like red, green, blue, and we put that in equation where y is just the value which can be used for red, green, and blue channel. If we use the same color for red, green, and blue channel, we receive the gray color. So that will be the black-white image in the end. Well, let's maybe take a look on some examples. So here we have it. Here we have it. Here we have with different symbols. Yeah. Well, guys, I can even show you how this thing works. I wrote that application in 2010, so a lot of years ago. We can create a templates of the English alphabet, and for example, we can draw something. Let's say I will be drawing letter T, and let's analyze it. So you see, with the probability, with the match percentage of 81%, a system thinks that I drawn the letter T. We can take something else. Well, let's suppose it will be A. Okay, I'm not really good at drawing of these things, but let's see. Oh, okay, it's different A. All right, it's different A. So I will have to draw it exactly as it appears in the template. Something like this. So you see, with the matching percentage of 73%, the algorithm thinks that I drawn the lowercase a letter. So how do you find this this example? Is it interesting? Mm-hmm. All right then. As you understand, for comparing, right, you will need to you will need to first, if you have the same sized images, then you can start with pixel comparison. If you would like to to sector the image, you can do that, and it's up to you by how many sectors you split in the image. But you have to have image which you're recognizing and templates. So yeah. And another thing, did you understand the principle of this method? How it's been implemented? So did you understand how this method works? Yes, checking for the most similar symbol. Exactly. So first you make a matrix from the image, and then you literally comparing different sectors. For example, you can imagine each of these squares you have here, right? You have here as arrays where you have zeros and ones, where 0 is the empty cell and 1 is the filled cell. Yeah, and I will be asking you guys to try to implement this method. As you have probably seen, I pulled such small task here, so you will have to try to implement this thing. And for making the long story short, I put you even the link in which you can find out how is it possible to get to the pixels and pixel components using Java. In the image, for the read function, if I remember correctly, it's possible even to set up the path on your computer for the image. So guys, would you be ready to try to make this? Not sure. Okay, what are you unsure about? Which knowledge is needed? Okay, if we have two arrays, can we compare values of corresponding index elements? Yes, it's possible. Okay, if we have the image, can we somehow can we somehow I don't know convert the image pixels to the matrix? Is that possible? Okay, you're guessing yes. Okay, so according to the link we have, let's suppose we would be having integer array, right, two dimensional, in which you would be having the pixel values. So the question is, if you have this array, how that would be possible um, to compress that to exact size array. Let's suppose 16 by 16 or 8 by 8. How that would be possible? Do you have any ideas? Okay, maybe no ideas. All right, then guys, I will maybe show you how I did that. So yeah, so I had the matrix, and yeah, okay, and I literally filled that matrix. So how? Well, that's pretty simple. Literally, what I could do, I could find out at which pixel each of the sectors starts and ends, um, and that was made both for the x and for the y um, directions. And then I just went through all of those areas where I already had x and y positions, where they start and where they ending. And I just collected amount of significant pixels and amount of overall pixels. And in the end, we can even make a division of the summated values by amount of all of the pixels. Well, something like that. If you need to make this part together, you can tell me, and we can do that together if you need. At least making the array from an image. Do we need to do that together? So what would you say, guys? Mm-hmm. Okay. Okay, then let's make that. All right. So yeah. So I will be making a new project then. Okay, well, I will use example which I shared with you. So, what I will be doing, I will be try to load some image, which I will be making afterwards. Okay. So, we will need to somehow read the image. So I will try to open I'll try to open the image of the URL. Okay, what I will be doing, I will take a look how to load that from the file in a fast way. Okay, great. The only I will need to have the image itself. Okay, so I will create somewhere a file. I don't know way to make that. For example, I will be maybe making something here. So I will use the print. I will make approximately such big image. Since I will be trying to use maybe known sizes, then I will be assuming that I will have such big image, and I will draw something inside. For example, I will draw with the huge marker the symbol 3. Let's suppose it will be this one. Okay, I'm saving that, and that will be saved as here. I will call that user image, because we will have to have image from the user to be recognized, and then we will have templated images. Okay, so I will have it on this on the C games and then user image dot png. Okay, so C games and this one. Do we need to have the exception? Oh, okay, we need an exception, but I wouldn't like to add it to the function. Then I would like to maybe use that of wrapping this thing. For example, then I will be saying that's equal to, oops, a bit. That will be equal to the null, and then the huge image will be equal to this one. Okay, and then I will be trying to use the try. This one. Yeah. And for the exception, I will need to have the class imported. Okay, so now we're not having the error. Well, why it was? Because potentially we couldn't have the image at this location. So that's why we have some mechanism which would ignore the error, the such error. Okay. So what will happen nextly? Nextly, I will be trying to make a conversion of the image to the integers. So I will be copying the texts, the codes from the one material I gave you, and I will need to add the function. Okay, where is it? Yeah, here. Oh no, definition should be outside. Yeah, so it will be there. All right. So the only thing I will be getting the RGB, and RGB is the integer. So, well, you know, actually, since we have three components in the RGB, it might happen we can somehow, you know, maybe we can somehow just take one of those components, not all of them. But let's see what types of values we will be having. Let's then go through these values. So it will be result point len for the rows, and for every of these rows, we'll be having the len. So literally columns, right? And then we will be printing out the value. So it will be system point out point print, and then it will be the result of the row and specific column, like this one. And in the end of each of the lines, we will need to have the enter sign, like this. All right, so let's take a look what we will be having there. Okay, we have something. But in this case, as you understand, we have the huge array, right? If we will be scrolling, we will see that we have some figure here, right? All right. Literally, the white color will mean -1, and a value which will be much smaller will be more close to the to the black color. So which means that we can literally print out this a bit in a bit different manner, if you like. we can do that in a way that if the value is equal to -1, then we will be printing a 0, an actual 0, for example. And otherwise, we will be printing a value of 1. So how that would be looking in this case? At least the output will be much smaller. Does it remind us something? Well, yes, a huge tree, right? Yeah. The only thing, it's not the matrix 16 by 16, right? So to have it, let's primary make such matrix. So we will be having, let's call it result 2, which will be the creation of the matrix 16 by 16. Okay. So nextly, we will need to go through the array of this one, and we will be somehow collecting data. Well, in what case? How it will happen? Maybe I will make the variable that will store amount of these elements, right? In this case, what I will be doing, I will be going through areas like 16 by 16. It will happen in a such way. And for each of these areas, I will try to go through the pixels. Again, how? Using this additional rows and columns. But the question, where will be the beginning and where will be the ending? And here we can use the basic equation. And what was the basic equation? We use the index of the element multiplied by the size of the element. And that will be until the next index of the same element, like this one. And similarly, it will happen for columns. Well, I suppose you know these equations because this is the very basic thing of IT mathematics. Yeah, so we'll be going through pixels. Well, for each of the sectors we're overlooking, we can make two so-called counting variables. So let's have it then. Let's say we are counting amount of all of the pixels, and we are counting amount of significant pixels only, right? So here, going through each of the pixels, we'll be seeing that, well, we are increasing amount of all pixels by, well, let's call it by 1, and only in the case when we have significant pixel, so it means the color is not -1, as you understood from the previous section, from this one, then that will be the significant pixel. So it means we will be increasing amount of significant pixels. And in the end, as you understand, I would rather I would rather use the double value. You know, you will understand why. Because next we'll need to include them into equation of division. So I will maybe better use doubles. So afterwards we need to somehow, store information about the row and the column of the sector. So that will be defined in the following manner. So if significant pixels divided by all pixels is bigger than 0.5, then it's 1, otherwise it will be a 0. Okay, I'm not, yeah, so, well, I suppose you understand this writing form. Okay, so literally, um, okay, maybe I will write this in the full form because maybe some of you don't understand what is it. So it's a regular if, and if that's so, then we have the case of the true branch, right? Otherwise, it's the opposite case when we have a 0. Well, something like this. And now we can again go through the array, but in this case it will be already the small array, that one which is called result2, and we will be just printing its values in the row. And we're clicking to run, and you will see that we will have the result. Oh, wait a bit. Yes. We have the problem because here I have to use n instead of that result and then the length. I have to use n. Okay, so let's run it. And what do we have here? Okay, not really much. You know, I suppose that's because of the amount amount of significant pixels is really small. So I will be just um, maybe doing this one, or maybe I will be using very small value for this. Okay, it might happen I will be printing out that that division then to understand what's going on there. Okay, it's kind of always zeros. Or maybe I mix the indexing here. Okay, looks like I mixed the indexing here. So to find out the beginning row, what should we do? Yes. What I had to do, I had to literally not to multiply that with n, but I had to multiply that with the size amount of rows divided by n. So we would find out how many rows are in one sector. Yes. So instead of n, I had to use then since the size of that image was 160, then I will need to divide this with n, convert it to the double, I suppose. Okay, let's run it again. Or maybe we don't really need to have the result in the double. Maybe it's enough only with integers. Like this one. Okay, let's see what we have related to the rows. The beginning row. No, all this is good. Then where did I have the mistake? Let's see. Oh, okay. So the mistake is here. Because I'm not checking the row 2 and column 2, but I was checking the row and column, which was the index of the sector. But initially, since they were just initialized, then the values were zeros. Yeah, so that's why I got that. Okay, let's run it again. Yeah, so now you see, in the array we can even see this symbol 3, right? So that's how it's doable. Okay, so maybe I will even share these codes with you. The only thing, maybe I will even take that image. I will put it here, so you would have it. And let's maybe call this one as image to matrix. Okay, so we have it, and I will upload that, so you would have these codes, because maybe these codes will help you. So guys, are we good so far with understanding how this conversion is happening? Is this algorithm clear for you? Okay, so the main thing is just to understand for each sector which pixels of the image which you saved into the matrix will be used. That's the main question actually. And if you have all of your sectors, well, for example, why did I write 160 divided with n? The size of the image was 160 in x and y directions. So literally, I tried to understand how many pixels in the row and in the column are inside one area's width and the height. Literally, that's why I made that division. Okay, so may I ask you guys to make at least two template images to have the arrays and try to compare them. Can you do that right now after this example? How do you think? Okay, guys. So, anyways, at least please try to do that. So please make several images for templates and compress them into the matrices. And you already have codes for that. And then try to compare them and find out the most close image to your analyzed one. Is the task clear for you? Guys, what would you say? Because I don't get when it's just a silence in the chat. Okay, then since no messages, then I suppose you already started to try it. Okay, so if there will be any troubles, let me know. So try to make this. So Faustinus, according to your question, in the first task we use the templated method, which converts image from the user received and several images from the library into arrays. And then we go through those arrays and we just compare elements of the arrays. And we find out which array is the most close to the user, from the user picture received one. But overall, you wrote correctly to read to image to the text. But you know, to read the image from to the text is well, it sounds very complicated. So just make the same as I did, but include in this process more images, not only one but several. Does it make a sense? Mm-hmm. Okay. So again, if you will have any questions, please write them. As well as if you will need me to show you something more, definitely inform me about that, and I will show you something more than those codes which I showed you already. All right, guys. So by the timing, I see that we are taking the small break. So let's take the small break and I will see you after the small break. Okay, guys, so looks like the break is over. All right, so please continue working on the project. And once you have some issues, once you have some questions, write them in the chat. Or if you would like to share your result or your progress, definitely post that in the chat. Guys, so how is your progress? Because I give you that code which basically converts image to the 16 by 16 matrix, and I suppose you could already do something. Making several different images, comparing arrays. Um, so how are you doing with all this? Or maybe I'm asking too fast. Maybe I need to give you some more time, maybe significantly more time, like a half an hour. If you feel so, you can write in the chat. Oh, okay, okay. All right. So I will ask you then after half an hour what is going on. But I will be here and I will be looking. I have the chat on one of my screens, so definitely I will be from time to time looking if you didn't write something. Okay, so half an hour is ready. Okay, and how half an hour is gone. So okay, there is something from Faustina's. Image should be comparable, not comparable, or more comparable, less comparable. Yes, and the more comparable is more likely that symbol which is drawn. So that's why you have to go through every of your saved image, of your saved character images, and you literally compare the image which you would like to recognize with those ones which are saved. And literally, what symbols did you put in the library. So if you have, let's suppose, uh, drawn, I don't know, let's say character tree, and you have in your library pictures with 1, 2, 3, 4, 5, and so on and so on. So more comparable, the drone symbol will be, for example, if you draw drone 3, then it should be more comparable to the image where you have symbol 3 drawn and saved into your database. Well, kind of database, relatively speaking. Did I answer your question? Okay, great. And since that half an hour gone, so what is the progress, guys? Okay, and while you're writing, I will check if in case someone uploaded solution. Oh, that's great. Let's see what we got from Rasa. Unfortunately, I cannot really check this because here we have pre-prepared symbols. Hmm. The code itself is good, actually. The code itself good. Yeah, really good one. But I would like to run this, so I will write the comment. Can I have all the images? Mm-hmm. Okay, anyways, here we have a good solution, a really good one. But what I think, okay, where was it? Okay, it was here. But the only thing it's um well, here we have the conversion to the kind of okay. Well, what I think here we have the only problematic is that looks like we have pixel by pixel comparison. Yes, looks like that. And that's the only kind of not really good thing. But if that would be just replaced with the region comparison, that would be much, much better. Okay, and what comparison type was used here? Um, so it's a method when we pixel distance, right? Here it's written. Literally, what is it? Here we have the square root of the difference. This is okay. This is not really what I showed in the slides, but this method is one of popular methods when we're about to find out the error in mathematical computations. Well, such method sometimes is, well, I would say that this method is used pretty often. The only thing we didn't have a talk about that. Um, but also this one works. Okay, so I suppose it could be that something is appearing in the chat. Oh no, nothing. Guys, do I understand correctly that that none of you finished at least on some level this project? Okay, do we have anyone who created a couple of images and pulled them into arrays? Okay, so silence in the chat. All right, all right. Is there anyone who made some steps forward? And oh, okay, Ben has posted the solution. Okay, let me take a look what we have there. Um, what's that? Okay. Oh, maybe it's not that. Wait a bit. Looks like I loaded incorrect one. Image. Yeah. All right, in my case, I will have to change those paths to the pictures. All right, so I'll take this pictures folder. I will put it this way. All right. So we take the first one, which is just a picture.png. Just a picture.png. Okay, yes. Yeah, and surely in person it will be more to the Windows 11 image one file. Yes, the only thing, here we use a lot of colors, and our code, which was mentioned here, literally it recognized that that -1 color, which was the white. So it means that well, we don't really okay. So this is the white. So besides the white, that means significant pixels. But guys, this method works only for the case when we have the background color and the foreground color. So two colors we haven't. Or a grayscale, for example, image. So there we would say that we have a white, black, and something in the middle. In this case, the recognition happened, but what's the reason why it happened? It happened only because of a different amount of white pixels in areas of the picture. That's only the reason why this recognition happened. There is no other reason for that. Does it make sense, Venus? Okay. Okay. All right. What about others? Guys, since we are working online, I have no idea what's happening on your computers. Maybe you're about to finish, maybe you're stuck, maybe you're somewhere in the middle, or maybe in the beginning. I have no idea. So please try to share the information more actively. Okay, silence in the chat. Okay, I see. So what should we do? Well, what if I would make an assumption that silence means that you don't need any help in it? Would I be correct in this assumption? Okay, Laurinus, it's good about it's good that you said that because well when no one is telling nothing, well, what can I understand from that? Okay, I will give a bit more time for sure. So the question from Benes, what about the next program? Well, about the next program, the story is super simple. We will be using neural networks. Well, we will already be talking about them, but what happens and how the neural network works when we have an image to recognize? So the story is the same as we were talking yesterday about neurons themselves. Well, the only thing is that for image analysis, we have to have several layers of neurons. And as you understand, guys, you can make arrays of them and you can make connections between them. For example, especially that's easy when, let's suppose you have the class where you have inputs which are references and you have all outputs which are references. Then it's doable very easy. What are those input values? Because remember, yesterday you were given numbers, right? And there were some mathematical equations. Well, in aspect of the image, we have those numbers as you can see, right? And you can imagine them that they have been extended into one line, right? And literally each of these symbols can be given to the inputs of the neural network. Literally, that's the way how that happens. And in the end, here we have kind of regions of values. For example, if the value is, let's suppose, between a 0 and 0.5, then that's a 0. When it's between 0.5 and 1.5, it's, for example, 1, and so on and so on. Literally, you are those who define which output values we should receive. And as you remember, the teaching process is needed. So during the teaching process, we modify the weights of the neural network, and by that, literally, we modify the output, which will be um, received um, when we will run the trained neural network. Literally, here I have a full theory of that. Literally the same as it was written in the slides where I had two examples of neural networks. When the first case was when there was one neuron with two connections, and the second case was with the neural network containing only two neurons. Yeah. So anyways, to make the long story short, you have all of equations. You can just follow that. Um, you can just follow that approach. And let's suppose if I would have um, such images to train the network, then here I would have different results which the network would give me related to such input images. How this works in reality? So here I have it. I will save the memory base, so I will train the network using such pictures. Great. And we already can recognize them, drawing them here. Well, recognition happens in the real-time case. So you see I'm drawing and the network tries to recognize what do I draw. Okay, so you see, this one more likely is 2 than any others. But here we cannot really say how many by the percentage or what is the next most recognizable previously used template for, well, which is the second close to my picture or whatever. So you can see I can draw in whatever way, for example, 4, like even this will be recognized as 4, even this will be recognized. Okay, this is more recognized as 1 because on the right side I don't have the 4 doesn't have such big tail as previously. Now it's more than, oh, okay, 8. That's strange. Okay, for example, let's draw 8. So you see that's 8. Let's draw 7. Okay, 7. Let's add line. It's still the 7. Let's make 1. Okay, you see it's 1. Yeah. So literally that's how that works. So again, you can take a look on this method of 2 neurons, and literally you can just continue working with such training method. You can extend that, for example, to several neurons in the row, or if you like, you can just have, for example, 2 layers of neurons. But you have to connect those neurons between themselves. So this is the second task. So anyways, you can at least try to make this. At least you can try to make several steps in its development. Maybe when there will be more students who will be starting doing this one, right? Then probably I will show how you can make this as easiest as you can. All right, so Benes, please try to make this, at least the beginning, and others, please continue working on that first project. Okay, so I have the question from Lorinus. Okay, yes, I can check your program. Yes, sure. Let's take a look what you have there. Okay, do we have some images? Okay, no, we don't. Okay, not a problem. I will just make the copy of of 1, 2, and then I will make original. So I'll take original. I will see it will be some original. Then I will have 1. Then I will have 2. Okay, here let's say I will have um we'll have 1. Okay. Here I will have 2. Mm-hmm. Then I will have some original image. Let's suppose here I will have 2 as well. Like this. All right, let's then run it. Image 2 is more comparable to the original image, and that's correctly. Okay, thank you. So that works well. So you can start to do the next application. Right, so if there will be any questions, go ahead and ask. Okay, guys, let's take the short break and let's continue after the short break. Okay, guys. So let's continue working on the programs. And do you have anyone who would like to share the progress which is so far created? Okay, looks like by the chat that not right now. Okay, so just keep working on the project, and once you will have issues, questions, or you would like to discuss your codes, let me know about this. And maybe if you will need some recommendations, especially for those who try the second application, well, let me know as well, and we'll figure out what you could start with at least. Guys, is there any progress you would like to share? Okay. All right. So just keep working on the project. Guys, time is moving on. So, is there any chance to see the progress, or maybe you can write a couple of words of what is created so far? Right, since there is kind of a silence in the chat, so put a plus if you're really here, just to make sure that all of you are here. So that's what I'm asking for now. Okay, makes sense. Okay, good. Do I understand correctly that you are still working and need some more, and literally that's it? Do I understand that correctly? So silence means yes or no. It's not clear for me because we're not in the class, so I cannot see what's going on your computers. So please, at least answer something. Okay, an explanation of the second task. Okay, great. So this is the neural network which you can create well in a way you like because I don't make any restrictions. And this is about the neural networks. Well, you can create a simplified neural network which literally receives those pixels. Well, actually, it's the same as I showed you previously. Um, so you can imagine that you have some neural network. It's up to you how big will be that. It could be even, let's say, it could be even one neuron or two neurons. That would be fine. It could be at least something. And what you do, you literally have the array of your symbol, right, of your picture, because you will convert that to the array, right? And we can literally give to each of the inputs one of the digits. So for example, this one goes for input 1, this one goes for input 2, this one goes for input 3, and so on and so on. And then the results, well, you can split a result in the values as you wish. For example, for the 0, it will be let's suppose the value from 0 to 0.5. Let's say for the 1 it will be from 0.5 to 1.5, and so on and so on. And by that you could have, let's say, 10 digits, right? So it means that literally you will have to train your network. Or if that's only one neuron, which you can definitely start with, that could be the one neuron. And then after the teaching process, you can give a picture, for example, a picture which was involved in a training process, and the network will recognize that image. It will give you the value. For example, for the value of 3, it would be, for example, in the range between 2.5 and 3.5. Окей. Значит, если по-русски надо, то окей, можно по-русски. Значит, смотрите, у вас же что получается? У вас есть картинка, которую мы сами переделали в матрицу. Мы можем каждый элемент матрицы дать для нейронной сети, как будто это какой-то x, как будто это какое-то вот входное значение. Ну вот, например, что вот каждый x это будет конкретный пиксель, ну или значение элемента матрицы, да. Это может быть даже один нейрон у вас. То есть вы можете один построить или можете целую сеть из них построить. Вы как бы попробуйте так, как вы придумаете. Вы, главное, потом напишите в коде, ну, что вы делаете. Вот. И потом у вас выходящее значение может соответствовать той цифре, которая была на картинке. Ну и, конечно, есть ожидаемый результат и есть реальный результат. Вот если вы помните, мы сами это делали с цифрами. И у нас есть ожидаемый результат и есть реальный результат. И мы с вами запускали процесс обучения нейронной сети. Ну, вообще-то нейроны или там двух нейронов у нас с вами была такая история. Ну и в результате, когда мы подаем уже реальные значения, обученные сети, мы получаем выходные значения как раз-таки в диапазоне, которое соответствует вот тому, что мы дали как input нашей нейронной сети. То есть вот если у нас есть стойка дана вот таким образом, то на выходе мы получим значение, скажем, от 2.5 до 3.5. Ну, другими словами, в пределах тройки, назовем это таким образом. Вот, в общем-то, и вся история насчет этого задания. Освальдес, вам понятно? Вам понятен общий принцип вообще вот нейроны и как он работает? Ну, по-моему, вы делали вот вчера задачи, разве нет? По-моему, там многие делали. Вот. Ну и, соответственно, таким образом вы сделаете проект этот.
Так, надо объединить прошлый проект с новым.
Если вы хотите, вы можете так пробовать делать, да.
Хорошо.
Если вы хотите, вы можете даже несколько слоев сделать в нейронной сети. То есть, ну вот как я на самом деле вначале говорил, я не даю вам какие-то рамки, не ставлю у вас какие-то рамки, как вам обязательно нужно сделать.
Понятно.
Мы с вами посмотрели, как работает, скажем, два, так сказать, слоя, да, как один слой работает. И я вам еще вот эту книжку загрузил, ну как, ссылку дал на нее, да. Там, кстати, я посмотрел ее сегодня, там очень хорошие примеры, действительно очень хорошие. Вот. Вы тоже и там можете посмотреть какие-то идеи, между прочим. Вот, поэтому, ну, попробуйте так, как у вас получится. Ну и в результате все равно вы всегда можете задать вопрос, мы всегда можем обсудить, а как нам нужно именно ваш конкретный проект, ну вот, скажем, направить в правильное направление, вот как его переделать лучше. Потому что, если помните, вот, вы и ваши коллеги еще, вы писали, что: "А вот посмотрите мой проект". Ну, и мы всегда смотрим их и изучаем, а как их можно улучшить, да. Вот точно так же можем и сейчас делать. Просто
Хорошо,
если
понял.
что-то непонятно, то вы не стесняйтесь, вы спрашиваете.
Если будет что непонятно, спрошу.
Очень хорошо, нечего стесняться. Я еще раз хочу подчеркнуть, что я не вижу ваши экраны, я не знаю, чем вы за компьютерами занимаетесь. Мы не находимся в кабинете, поэтому, ну, как-то поживее, если бы коммуникация в чате была, это было бы более понятно, что происходит на данный момент. Ладно, тогда если на этом все, тогда пробуйте, и как только появятся вопросы, задавайте их.
Хорошо.
Guys, the time is moving on, and soon today's classes will be finished. But we have some 10 minutes, approximately, if I'm not mistaken. So maybe some of you can share your results, and we can discuss what you have so far, if you like, because we still have some time for that. Because afterwards I will have another session I will have to be connected to. So since we have some small amount of time, but still we have, then we can make some discussions if you need them for sure. Oh, so Laurinus, you're working on something besides our Java things, right? Oh, on the world too. Okay. Okay, makes sense. Makes sense. All right. Mhm. Okay, Lorenz, about you, it's clear. Well, yes, you just need some more time. What about others? Okay, that's one hard to balance. You mean you created the neural network and you are kind of trying to teach that, right? So there you have problems. Uh, did I understand correctly? Or it's overly um, still kind of complicated. Oh, okay, Carlos. So you were talking about the word two, right? Okay, yes, looks like that. Okay, maybe. Right. It might happen that before. Well, as you understood, guys, right? Even on the next week, instead of Wednesday, we have Tuesday. So I suppose that's always, but again, I would like just to remind us. I will try before our next classes on Tuesday to prepare you a couple of solutions for these neural networks, and I'm gonna show you a few ways how we can make that. Um, maybe then it will be a bit easier for you to create a solution. Although, frankly saying, those projects which were done related um, to the neural networks, to the neural, well, they were pretty nicely made, anyways. So I suppose the overall idea is clear. Okay. Will we have some comments from others? Maybe Alona, Nikita, or Oswaldus, maybe you guys would like to write some comments. Okay, Oswaldus, understood. Right. Right. Um, so looks like those are all comments from your side, guys, right? All right. Well, if you like, you can always share what you have so far, because we have still some short time. And if not, then we can just finish today's classes. All right. I don't really have any record that someone would be writing or typing something in the chat. So I suppose that means no questions, no comments so far. Okay, then. So we're finishing classes for today. Thank you for joining the classes. I will try to, until the Tuesday, prepare a couple of those projects. Frank is saying almost no time for doing this, but I will try to find some time for that. All right, guys. So see you on Tuesday. So we are starting at 9, right? And I already almost created you materials about the databases. So we will definitely continue what we're working on right now, and after that we will reach to connections to databases. Right. So see you guys on Tuesday and have a nice weekend. Bye bye, guys.